Okay. In this video, I'll explain the numericals based on the refraction, which is the Snell's law. Okay. We will do some numericals based on it. So the first one is a light ray of wavelength 589 nanometer traveling through air is incident on a smooth flat slab of ground glass at an angle of 30 degree to the normal. Okay. So the first thing when you are doing the refraction questions, you need to make a diagram. Okay. So how to create a diagram? I'll explain you the first one. Okay. So first of all, just create a medium. Okay. And then see what is given in the question. A light ray of wavelength 589 nanometer traveling through air is incident on a, so basically this medium is air, on a flat slab of ground glass. Basically this is ground glass, and then again this is your air. Okay, I've explained you the refraction, how to create the diagram in the previous video. After that you need to create a normal line like this. Okay, when you are creating the normal line, I've explained you normal line must be dotted. Okay, now we need to see light ray of wavelength is given to you and it is making an angle 30 degree to the normal. So this angle is 30 degree. Okay, this angle is 30 degree. Okay, find the angle of refraction. We need to find that this ray will be bent. Okay, this ray will be bent towards the normal or away from the normal. So we need to find out this angle. Okay, and this is your normal line N. Okay, so we will use this formula as discussed in my previous lecture. N1 sine theta 1 equals to N2 sine theta 2. Okay, what is theta 1? Theta 1 is angle of incidence, and what is theta 2? Angle of refraction. Okay, so N, and what is N1? Refractive index of the first medium. That means here the first medium is air and second medium is glass. N2 refractive index of second medium. Okay, this is the refraction equation. We will put all the values. N1 sine, what is theta 1? 30 degree. N2 sine theta 2 we need to find out. So we need to find out what is theta 2. Okay. So N of air, always remember refractive index of air is always 1. Okay, and glass is 1.52. So these refractive index will be given to you in the formula sheet. You need to check from there what is the refractive index of glass, what is the refractive index of air. Okay, so we will use this and we will put all the values, and we have find out theta 2 equals to 19.2 degree. And what is theta 2? This is basically the angle of refraction. Okay, and see now it is 19.2 degree. That means it is lesser than 30 degree. 19.2 degree. So we have find out this is 19.2 degree. So the ray will be bent towards the normal. Okay, now the B part, find the speed of the light once it enters the glass. So for this I have discussed in my previous video. What is the formula? N equals to C by V. Okay, N is the refractive index, C is the speed of light, and then V is the speed in the medium. Okay, so we need to find the V. V equals to 3 into 10 to the power 8 by 1.52. Refractive index 1.52 is given. So we will find out this is V. That means speed of the light once it enters the glass. So this is basically the speed of light when entering into glass. Okay, next is what is the wavelength of this light in the glass. Okay, so for wavelength this formula needs to use. This is the relationship between the refractive index and the wavelength. N equals to lambda over lambda n. So N is given 1.52 refractive index. Lambda 589 nanometers. See, it is given here. A light ray of wavelength 589 nanometer. Okay. And lambda n we need to find out. Wavelength in the medium. Okay. So lambda n equals to this and lambda n equals to 388 nanometer. So this is the answer. So where n equals to refractive index, lambda n equals to wavelength of light in medium whose refractive index is n, and lambda equals to wavelength of light in vacuum. Okay, so if you need to do the formulas, the numericals of refractive index, you need to remember these three formulas. The first one, the Snell's law, n1 sine theta 1 equals to n2 sine theta 2. Second equals to n equals to c by v. And third equals to n equals to lambda over lambda n. Okay. Okay, now the second one. Determine the speed of light in a flint glass with an index of refraction of 1.02. Okay, that means n is given to you. N is given to you, what is 1.02? Okay, and you need to find the speed of light. And C, you all know 3 into 10 to the power 8 meter per second. Always remember, when some question is given, you need to write what is given to you. Okay, this is given to you. Then calculations and formula used. Okay, so n equals to c by v. N is given to you 1.02, c is 3 into 10 to the power 8, and we need to find out. So v will be 2.94 meter per second. So this is the answer. So remember, only 2 or 3 formulas you need to remember. So this is one of the formula. Okay. The third one. A light ray is incident at an angle of 45 degree from the normal onto a solution of linseed oil in water. The beam is refracted to 35 degree from the normal. Okay. That means angle of incidence and angle of refraction. Both are given to you. So this is 45 degree angle of incidence and this is 35 degree angle of refraction. Okay. Draw the diagram of the light ray and linseed oil. First of all, the diagram you need to. Second is, you need to find the index of refraction. That means you need to find n. Okay. Okay, let us do the first one. It's very simple. The first one, this is the normal. Normal. First of all, you need to make this medium. Okay. The medium is there. Then you create the normal. And then angle of incidence, I, equals to 45 degrees given, and angle R equals to 35 degrees given. Okay, this is given to you. A is done. And N air, obviously this is the medium, this will be air. So N air will be 1 and N linseed we need to find out. Okay, so we know this formula. N1 sine theta 1 equals to N2 sine theta 2. Okay, so N2 equals to N1 sine theta 1 over sine theta 2. And N2 equals to, we will put all the values and we will find N2 equals to 1.23. So this is the answer. C part. Now, assume the light ray is having the wavelength of 500 nanometers. So 500 nanometer wavelength is given. Find the frequency of the ray in the linseed solution. So how to find out the frequency? You all know frequency and the wavelength. The relation C equals to F lambda. Okay. So F equals to C by lambda. C is 3 into 10 to the power 8 and lambda is 500 into 10 to the power minus 9 is given to you. And then we will find out the frequency. Simple direct formula. D part, find the speed of the ray in the linseed solution. So N equals to C by V. N is the refractive index which is given to you 1.23. Check, we already find out 1.23. So it is 1.23 and then C is 3.28. We have put the values and V equals to 2.43 into 10 to the power 8 meter per second. So this is the speed of the ray in the medium. Okay, as we used in question number first. And the last one, E part, find the wavelength of the beam in the linseed solution. So lambda equals to V by F, simple formula, and then we will put the values. V equals to 2.43, we have find out now in the D part, and F equals to 6 into 10 to the power 14. It is, we have find out here, and we put the values and we find out the lambda, this 4.05 into 10 to the power minus 7 meter. You can please check the calculations because I have solved by myself, so please check all the calculations. Okay, now question number 4. The figure below shows the diagram when the light ray passed through several layers having different indices of refraction. If theta 1 equals to 35 degree, determine theta 2 and theta 3. It's very simple. A diagram is given to you. This is medium number 1. This is medium number 2. You can see this is one normal n dash. This is another normal n dash. And one ray is incident and which is making angle theta 1. And another, we need to find out this angle. And then theta 2. And we need to find out this angle and this angle. Okay. So this is the question here. Just remove this. Okay. So how do we find out? Simple formula. Medium 1 to 2. When the light ray is traveling from this medium to this medium. So we will put n1 sine theta 1 equals to n2 sine theta 2. Okay. This is the formula and it is given n1 equals to 1.5. It is given and n2 equals to 1.8. So we will put 1.5 sine 35 equals to 1.8 sine theta 2. We need to find theta 2. We'll put all the values, we will do the calculations and we see the theta 2 is 28.48 degree. Okay, this is your theta 2. Now, so this one we find out it is 28.48 degree. Theta 1 is 35 degree. Okay, now because I have mentioned it here because it is 28.45, so this ray will be bent towards the normal. Okay, now if this is theta 2 and this is also theta 2, so this angle will be same, 28.48 degree. These both angles will be same. Okay, if these both angles will be same, then we will again find out, we need to find out this angle now. Let us mention it is theta 3 dash. Okay, let me just do it with another color. Let us say theta 3 dash. Okay, so we will find out this angle first. So now we will again do this. N2 sine theta 2 equals to N3 sine theta 3 dash, and then we will put the values. N2 is now 1.8 and now it is going to air. Air is 1. So we'll put the values 1 and we'll find out theta 3 dash equals to 59.12 degree. Okay. Now it is 59.12 degree, but we need to find out this angle. So you can see this whole angle is 90 degree. Okay. So what we will do, 90 degree minus theta 3 dash will be equal to theta 3. Okay. We will get that angle. So what I have done, I have subtracted 90 degree minus this angle and I got the final answer of theta 3. Okay, this was numerical number 4. Now numerical number 5. Figure shows a refracted light beam in linseed oil making an angle phi equals to 20 degree with the normal line n dash. The index of refraction of linseed oil is 1.48. Determine the angles theta and phi dash, theta dash. So very simple. So here it is showing that, what it is showing, figure shows a refracted light making an angle phi with the normal line this. Okay, now the angle refraction is given to you. This angle is given to you, phi. Okay, this angle is given to you. And you need to find the theta and phi. Now the first one, from air to linseed oil, n1 sine theta equals to n2 sine phi, right? Air 1 is given, sine theta equals to 1.48 sine 20 degree. 20 degree is given to you. So we'll find out theta equals to 30.39. That means we have find out this angle 30.39 degree. Okay. Now this is phi. So this angle and this angle will be same. Now again from linseed oil to water, if we do this formula, okay, so it will be n2 sine phi equals to n3 sine theta dash. We'll put the values 1.48. Linseed oil refraction is 1.48. Sine 20 degree equals to n3 1.33. N of water is 1.33. Sine theta 1. Theta dash. So now we will find out the theta dash, which is equal to 22.37 degree. So this angle come out to be 22.37 degree. Okay. So it's very, very simple. You just need to apply these formulas and you need to see what are the refractive index. Refractive index will always be given in the question. If not given, you need check to formula sheet. It will be given there. Okay. Now this one. Question number 6. Figure shows a light ray traveling through different mediums. Rank the mediums according to the index of refraction from largest to smallest. Okay. So when such type of questions are given to you, you need to draw a normal ray. Okay, like this. A normal ray. Okay. Suppose a medium is given to you like this. A medium is given to you like this. A ray is incident here and it is refractive here. So you need to draw a normal here. So this is I and this is R. Okay. So you can check what is given to you. Now look here. Figure shows a light ray traveling through different mediums. Rank the mediums according to the index of refraction from largest to smallest. Okay. So we know the formula n equals to sine I over sine R. That means n is dependent on R, angle of refraction. So if angle of refraction is less, that means n will be high. Right? N will be high. So what now we can see here. Okay. So in all these three figures, okay. So maybe we can see this angle, the lowest angle is this one. Let us say this is, let us say just 10 degree. And then second number is this, let us say it is 20 degree. And then let us say it is 30 degree. So in C figure, okay, in C, R is less. In B, okay, I'm just doing the order. C, A and B. Okay. So I just did the order according to refraction angle. Okay. So C has less angle 10 degree. Let us say it is having 20 degree and let us say it is having 30 degree. I have just assumed so that you know. So I said R is less, then N will be higher. So in wherever R is less, so 10, so N will be higher, this will be more higher, and then N will be less higher and N will be this. Okay, you understand this? Because these both are inversely proportional to each other. And here it will be, this is refractive index. So this is refractive index and this is N. Okay, now we need to do it from largest to smallest. N from largest to smallest. So N largest to smallest, that means C, A, B. So C will be greater, A will be greater, and this will be the. So this is your answer. Okay, I hope you will understand this question. Okay, thank you so much.